All right, so here's the last step we're going to do. We're actually going to define the load case, and then we're going to export the Nastran file and then look at it, okay? And actually, we'll have to do a little editing to get it to run, okay? So let's close this. Let's go back to our model. Here we are. The last thing we have to do is define the load steps. Okay, we've got the load collectors defined, but we have to organize them and say, okay, for this load step, I want to look at using these forces and these constraints. Okay, so the load step is done under analysis, and I guess it's up here too somewhere. Tools, I don't know what it is. Setup, maybe it's setup. Create load step. Yeah, it'd be the same. You get the same thing either way. So we do load step. We give it a name. We can just call it tension, okay, because that's what it is. It's a tension. Now, the two that we're most worried about is picking the SPC and load. You can also, we haven't talked about multiple point constraints or temperature boundary conditions. So we're going to pick these guys. So if you click on those, it activates those. And then here you've got it equals 0. This is the set ID. So you pick the equal sign, and this allows you to pick the load collector. So the SPC, we want to use all the loads that are defined on this SPC level. And for load, we want this to be the forces that are edge force. So this you can see, looks just like the subcase thing for Nastran, right? SPC equals 1, load equals 2. All right? And then you create. Leave this as linear static. You know, this allows you to do other types of analysis like normal loads and so on and so forth, but we're doing linear static. And there you go. So now we've got a new load step. And I believe I can do a card edit. And you can see it gives you the subcase, right? And now actually on this little option thing, I can even do stuff like set the output, you know, the little optional statements in there. So we can set the output, we can set the displacement, because we like to do that one. Set it to all. We can set also, we like to see usually the SPC forces. And these are the different options. You can see down here. We have displacement and all. And I can change the SPC from all to like sorting. We're not going to use that, we're just keep it at all. And then we want to do, well, we'll do stress. Those are by default. Stress and strain are usually put out there. And the last one I want to do is let's put the element forces. And I don't know whether they have, do they have force? There's EF. They don't have force, but they have L force, which is the same thing, okay? And now you can go through and you can see the subcase. It doesn't show you which, the set IDs, because that's inferred by the definition, but it shows you the output options. So we're outputting all the displacements, the element forces, the SPC forces, the strains, and the stresses. So a lot of times, like under strain, or stress, we would export the Mises stress. So you could go down here and add in Mises, I think. Stress. You can change this to, no, that's not it. That changes where it is. Format, print, punch, that's not the one I want. Form, real imaginary, that's not it. Optional. Yeah, okay, whatever. I'll just leave it that way, that's fine. Okay? And you hit return. Okay? And now we're pretty much done, okay? So we've added in the load cases. Actually, if you there are other, you can add in other unsupported cards in here, like a title. You know, sometimes we put in a title, and you can put in just give it a name. Plate with hole under tension. That creates the title card. Okay, you can see it gets used. And actually, under here, the optional card, you can go and you can edit the card. You can see it's the same way as it would look in Nastran, right? I think those are probably the big ones, but you could put other ones in here. I don't think there's anything else in here that we've used. But anyway, The control cards has some good options in it too. All right, so now we're done. The model is fully defined. Everything's in there. Now we just have to export the Nastran file and then solve it in Nastran. So to export it, you go under File, Export, and we're going to export the solver deck, okay? So that's what we want to do. So export the solver deck. It's using Nastran, standard format, and now we'll just give it a file name, okay? So I'm going to save it under where I keep all that stuff. I'll just put, yeah, I'll put it under Dropbox. Applied FEA. Do it right here. Okay, so we'll call it plate.pdf. Okay, and then there's actually export options. You can export everything or what's displayed and some of these other ones, but for the most part, we just go with export everything. Let's just make sure it has export everything. Export all. Let's just make sure that it says export all. What you can do is you can export only the stuff that's displayed, but everything's displayed anyway, so do export all. And I think it exported it. So now if I go to the directory and actually look at it, I should see that PDF file. And do I see it? Here it is. Here's plate.pdf. So that's the input file that Hypermesh just wrote. So I can open it up with the text editor. And here it is. Let me bring it over here so I make sure I'm on the screen, right? So this is actually the input file that Hypermesh wrote. So you can see there's no problems generating all those cards, right? And that's the nice thing about it. But you do want to go back and just make sure that everything is still here, right? So what you'll notice is missing is the solver card. I never specified the solver, okay? And actually, I could do that under control cards. You can see here, if I do control cards, solver, we can set it to statics and write solver 101. But let's say I didn't do that, you know, now I'd have to re-export it, but let's just say I didn't do that and I wanted to add it in later. All I need to do is just actually go into here and you can just type it in, oops, 101, yourself. So even if Hypermesh is not outputting exactly what you want, you always have the option to go back in and edit the PDF file, okay? So this is why I make you go through and the pains of writing your own PDF files by hand to start with, because sometimes you just have to go in and do it, okay? So there's the elements, there's the nodes. Oh, this is just some weird thing. I don't know what Hypermesh is doing there. Here's the plate property. Well, it just got deleted out, but here's the plate property, okay, P shell. Here's the material definition. Here are the SPCs, and here are the forces, and that's it, okay? So this should be good, all right? We should be able to run this in Nastran. Okay, let's close this down. Actually, I should just save it. Let's just save it to be on the safe side. So it's saved, minimize it, and now I should be able to run that file using Nastran, just like we did it with the files that you made by hand. So we go under MSC Software, Nastran, and now let's pick the file. There is the plate.pdf, and we should be able to run it. And now I'll just go check that it didn't give me any errors. It's thinking. You can see here, it's actually starting to write the files to my drive, cleans that up. Looks like it's done now. Here's the .fo6. Let's open that up and see what that looks like. Make sure I didn't get any errors. Here's the .fo6. And it looks looks good. Okay, it looks like it solved everything. So it's got all the quadrilateral information, and all the displacement vectors, all the info's in here. Okay. Yep, stresses, all that good stuff. Okay, so it seemed like it works. Okay. Actually, I'll show you how we can, in another video, I'll show you how we can actually post-process that stuff in Hyper-V, okay? But I think we'll stop for now.